Okay, so 2.3, the derivative of a polynomial function, the derivative of y equals e to the x is what we're going to look at today. So before getting started, we introduce other notations commonly used for the derivative. So if they say y equals f of x, they could ask you for y prime. That means the first derivative. They could ask you for dy over dx, which means the derivative of y with respect to the derivative of x. That's what the d means. Or they could say f prime of x. Or they could say differentiate or determine the derivative, all of which mean the same thing. Okay. So then we have Leibniz notation. Dy dx may be written in several different ways. They can go dy over dx, which is often the way it's written, or d over dx, so that means the derivative of y with respect to x, or this is the derivative of y, just y being f of x, right? So they're all just different notations. And honestly, when you go to university, you're just going to use whatever notation your prof likes better. But in AP, you could have either. They can ask it anyway. Okay. So we're going to differentiate a constant function. A constant function is a function without a variable, right? So the theorem is the derivative of a constant function. So if f is a constant function where f of x equals a, then f prime of x equals 0. So whenever we have a constant function like 7 or 5 or 6, and we take the derivative of those, they just become zeros. Why? Well, here's the proof. So if we have f of x equals a, and this is why we learned limits before, because if not, you're just trusting that what rules I'm telling you is true. If we wanted to find the derivative of a limit and we didn't have it at an instantaneous rate, we'd put it into that limit as h approaches 0, f of x plus h minus f of x all over h. That's the only way we've been able to find derivatives until this point, right? So if we plugged in x plus h for all the x's in f of x, a is just a number like 7. Does it have an x? No. So it would just stay a, right? And then for f of x, it would just be a, correct? So we'd have a minus a over h. What's a minus a? 0. So it would always be 0. So if you use the limit formula, it would prove that it becomes 0. So whenever we have the derivative of a constant like a 7 or a -2 or a 4 or pi, because pi is just a constant, it's not a variable, or e is just a constant, it's like 2.71 something, something, something. It's like pi, but it's used more in calculus. So if you did e to the 1, it would give you a non-repeating, non-terminating decimal just like pi. Then the derivative of those would all be zeros. Okay? Now, let's go here. We have the power rule. So the power rule, the derivative of power function. So you have to have a variable to an exponent that is a number. So like if you had a variable to a variable exponent, this doesn't work. This only works if you basically have a polynomial, or even a rational exponent would work. But whatever is in the exponent has to be a number. It could be a fractional number, it could be a negative number, it could be an integer, right? But it has to be a number. So we could have x to the half and still use the power rule. We could have x to the 7 and still use the power rule. If we had x to the x, we can't use the power rule. Okay? So in the exponent, it needs to be a number. All right? So when using the power rule, the derivative of the power function y equals x to the n, where n has to be greater than 1, is an integer, is this. So what we do is we take the variable, it drops in front, and then we drop it by 1 number. That's what this means. So if I have x to the n, I'm going to take whatever n is, I'm going to drop it in front, and then I'm going to reduce n by 1. That's the actual official formula. Why did they say it that way? Because you can use it for every single power rule question, right? Using variables. So what does that look like in a real life example? So example 1, find the derivative of each of the following. So we have 5x cubed. Does it follow my rule? I have a variable to an exponent that's a number. Yes, so then I can use the power rule. So I take the 3, I drop it in front. So I'm going to get f prime of x. That's my most liked method. I like writing f prime of x. I only use the other ones like dy over dx or y prime if I'm forced to. Other than that, I just prime whatever the heck the f of x is. So we're going to take our 5, and we're going to have the 5 in front. We take our 3. We drop it in front. We rewrite the x, and then our exponent reduces by 1. So now it's going to be a 2. So the derivative is 15x squared. Yep, the first derivative. Now, until this very point, when I would give you questions like this, I'd say, oh, the derivative is 15x squared. And you'd look at me like, how do you know that? Because you guys would be going, limit as h approaches 0, f of x plus h cubed. So you'd have to expand x plus h out 3 times, right? Then you'd minus f of x cubed, and then you'd go over h, right? And then you'd expand it all out. You'd collect like terms. You'd make sure every term that didn't have an h would go away. You take a GCF of h out. You cross the h's off. You plug it in, and you get an answer of 15x squared. Right? When in reality, I was like, okay, take the exponent, drop it in front, 15x squared. And I could note because I knew power rule. All right? So using that limit would prove that this works. All right? Yeah.
So is the second derivative 30x?
Yeah. The second derivative would be 30x, and you just keep going. Yeah. Okay. This one. G of u equals negative a half u squared. So I'm going to get g prime of u equals negative a half. Then what do I do? Bring the 2 down. U to the 1. So I'm actually going to get negative u. For C, pi to the 4 x cubed, right now you're going to do power rule because it's the only thing I've taught you. But tomorrow we do product rule, and you guys will try and do product rule. You're going to say that this is multiplied by this, and it's 2 variables multiplied. Is pi a variable? No, pi is a constant. It's a number, right? This is 3.14159 da, 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 to the power of 4. It's equally as numerical as negative a half as 5. Right? It's the same thing. It's a number. It's really awful. Don't get me wrong. Pi to the 4. That just sounds wonderful, you know? Like if I'm going to pick a number, it's between 1 and 100. I always like to pick pi to the 4. You know, it's going to have to be bigger than that. What is pi to the 4?
97.4.
Oh, it does fit right before. I thought it was going to be a little bit over, but it didn't. I thought the decimals would bump me. So if I'm picked between 1 and 100, I always pick pi to the 4. I just decided that. Everyone's going to be like, no.
No other guess. Other pi to the
Yes. He's a rebel. So we're going to get u. So why did if I started with an equal sign here, I'd be wrong, right? If I went equals this, it doesn't, right? I'm starting with a whole new statement. What's my statement? U prime of x. And it equals pi to the 4. What do I do next? Bring the 3 in. X to the 2. So I would really write that as 3 pi 4 x squared. I would never turn that into a decimal, because if you turn it into a decimal, what are you rounding to? Because pi does not round. But pi doesn't round. You would be rounding it, and then that's not actually the right answer. No, if you went 3 times pi to the 4 and gave me a rounded number, then that's actually not the derivative of the previous question. Yeah. Unless I asked you to round it, but not in this. Yeah.
First, if I wrote du dx separately.
Yep. Yep. Okay. This is f prime of x equals, what are we going to get? 3 times 2 x to the 1. Now I want to prove why a constant goes away using power rule. What is the variable on 8? X to the 0. It's x to the 0, isn't it? Right? If there is not a variable, you put a variable and you have to raise to the power of 0, because anything to the power of 0 is 1. So what would I do using power rule? I'd write the 8, I'd times it by 0, and I'd go x to the negative 1, correct? But this is all multiplied by 0, isn't it? So it would just go away. So power rule shows that it actually goes away as well. So your answer would be f prime of x equals 6x. without having to go 3, or limit as h approaches 0, 3x plus h squared, FOIL that out, plus 8 minus 3x squared minus 8, because I have to remember to distribute the negative sign, all over h, expand it, cancel everything that doesn't have h's, take out an h, cancel off h's, plug in 0, get answer of 6x. I just did power rule. Boom. Done. Yes. All right. This one, people will say quotient rule from now on, but you won't say that because you don't know about quotient rules. So this one, what you need to remember is this. You can use a quotient rule later, and you're going to, quotient rule is g times f prime minus f times g prime over g squared. That sounds complicated, doesn't it? I meant to say it fast so it sounded complicated. What you need to remember is when you have a number in the denominator, you can actually just divide each term by it, and then you don't have a denominator, you have a coefficient. Remember? So I've told you this before. You guys remember that if I give you a half x plus 3 halves, that you can write that as x plus 3 over 2. You all agree that that's golden, the common denominator. What you forget, though, is that if you have a common denominator, you can actually split each term over that denominator, and then it becomes coefficients, not a denominator anymore. So if I have a division of 9, before I even go to do this question, right now I can't do power rule because I have a 9 on the bottom. I need to have coefficient variable to a number exponent plus or minus, coefficient to variable to a number exponent plus or minus. You know what I mean? That's what you have to do in order to do power rule. I'm not in that form. So I'm going to have to go f of x equals, now this has a 1 in front. So when I divide it by 9, I'm actually going to get 1 over 9 x to the 7 minus what? 5 over 9x. Now instead of it being a denominator, that 9 becomes part of your coefficient. And then we can do power rule again, right? So we're going to take the 7, so we're going to go f prime of x. Take the 7, drop it in front with that 9th. So 1/9 times 7, x to the 6. This is to the 1. So I'm going to go negative 5 over 9 times 1, x to the 0. So actually, this is something to note. Constants go away, right? There's nothing left, they turn to 0. Anything to the power of 1, the variable is just going to go away and you're going to be left with the number. Because when you multiply that number by 1, it just stays the same, and x to the 0 is just 1. So whenever you actually have anything x to the 1, you're just going to end up with a coefficient. So we're going to end up with 7 over 9 x to the 6 minus 5 over 9. Can you imagine doing this one in the x plus h's? It would take forever. So, example 2, differentiating a polynomial function. So now we're going to do exactly what we did before. We're going to find slope of tangent. We're going to find slope of normal. We're going to get the equation of a line, right? All this stuff, but we are not having to go limit as h approaches 0 of f of x plus h minus f of x all over h. We don't have to do that ugliness anymore. We can just use power rule, get ourselves a little tangent, call it a day, right? All right. So we want us to find the derivative. Now, I know I can use power rule because I have coefficients sitting in front. I have variables all to numerical exponents, right? This one would be to the 1. Technically, this would be to the 0. All of them are variables to numerical exponents. We agree? So A is going to be f prime of x, that's the derivative, equals, take the 2, drop the 4 in front, x to the 3 minus 6, drop the 2 in front, x to the 1, plus 2 times 1, x to the 0, minus 3 times 0, x to the negative 1, done. Do I need to show all that work where the rest go away? No, I just need to remember that if it's x to the 1, it's just going to be this number. If it's just a constant, it goes away. So I'm going to end up with 8x cubed minus 12x plus 2. So there's my first derivative. Imagine this polynomial being filled in with x plus h's. It would be fun. Yes, totally. So B says you're going to still need to know how to do the x plus h filling in because it's on your unit test, but that's okay. B says, what is f prime of 2? What does that mean? On the first derivative, you sub in 2 for the x's, right? And it's because we have function notation here, and this is a prime, so I have to fill it into the prime equation. So what is that actually meaning? What are they indirectly asking you to find when they do f prime of 2? Instantaneous slope, right? So they're asking for the slope of the tangent at a specific point, the point being 2 and some certain y value. How would I get the y value at that point? You plug it into where? You substitute it into where? The original, not the first derivative. We plug it into the original because we want to point off the graph, the original graph, not the derivative graph. So if I wanted to find the equation with a slope at 2, or a slope when x is 2, I'd have to plug that 2 back into the original to get my y, because I need to point off the original. You need to point off the original. Yeah, that's getting you the slope. And then you still have to plug in your original point to get the equation of the line. When you plug in f prime of 2, let's plug it in. So we're going to get 8 times 2 cubed minus 12 times 2 plus 2. So we're going to get 8 times 8 minus 24 plus 2. You should be able to do this without your calculator. If not, that's sad. 64 minus 24 plus 2 is 40 plus 2 is 40 plus 2 is 41. Okay, we're going to go with 42.
If B is the instantaneous slope, similar to A.
General. So I can fill in any x value and get a tangent slope. So this is my general slope. This is my general slope of every single tangent slope on the entire graph. And if I plugged in 1, I'd get the tangent slope at 0.1 and something.
But if you were to graph that, would it have any like relation to the original graph?
If you're
B would be like a tangent to
at 2.
2.
Yeah.
If you
So
graph
what?
A, would it really be?
When you graph A, we're going to deal with that in the next unit. When you go to graph A, when you go to graph the first derivative of something, wherever it's equal to 0 is actually where you're going to have maxes and mins. And we actually deal with that in this lesson as well. So right now we're just learning how to find the derivatives, and then we're going to go with what the heck does it give me? How does it draw graphs? Yeah, what does it mean? So the first derivative, the answer to any x value, the y values, this is a coordinate on the, this is actually a coordinate, 2 and 42, correct? But it's a coordinate on the what graph? The derivative graph. And what is the y value on the derivative graph always give you? The tangent slope of this x value, doesn't it? Right? So if I went to go draw an equation of a line, I would need the y value from the original, not the y value from here. This is a tangent slope. Right? Let's go on. It'll make sense in a second. So we look at C. C says find the tangent line to the graph at 1 and -5. No, that's if you have to find a tangent equation. I don't have to. That's the answer. It's just asking what's f prime of 2. F prime of 2 is 42. I said if I had to go and actually make the equation of a line with that slope of a tangent, I'd have to fill 2 back into here to get my y value. So I have a coordinate 2 and whatever. And I can use that as my x and my y. And then this is my slope. Put it into point slope form. Boom. I have my equation. So we're going to look at C. C says find the slope of the tangent line to 1 and -5. Where the heck did they get this -5? Because they don't need to give it to me. They could have just said x equals 1. The first equation. If I plugged 1 back into here, 2 times 2, and then 1 to the 4 is 2, minus 6 and 1 to the 2 is 1, plus 2 times 1 minus 3. If I filled 1 into this equation, I would get its corresponding y value, which is -5. And I'd have a point. Often you're not actually given the y value. Sometimes you're just given the x and you have to find the y, but the y is off of your original. It's an original point, correct, on the graph. So we just need to find the slope. Finding the slope means plugging it into the derivative, right? So if they want the slope at 1, they're really asking me to find f prime of 1. Because f prime is my tangent slope. They want it at 1. We agree? So do I have to go find the derivative all again? No, I found the derivative in A. That was a general tangent slope, correct? Now I can plug my x into it and find every tangent slope on it. Into the f of x minus f of c over x minus c. Limit as x approaches c. Yep. And now we just go plug 1s into there. Boom, we have the answer. Way faster. Eight minus 12 plus 2. And so I get -2. So I have a coordinate at 1 and -2 on the derivative graph, correct? What does the point on the derivative graph mean? This is my x, this is my m tan. Right? My y value on my first derivative graph is always my tangent at the x value. So they want us to find the slope of the tangent line. This is m tangent. So if I went to sketch this graph, the original graph, 2x4 minus 6x squared plus 2x minus 3, I would get a quadratic, I would get a degree 4 function that looks like a W because it's positive, because my leading coefficient is positive. So it would be up on the right and up on the left, right? Because my leading coefficient tells me how I end on the left. End on the right, you're right. End on the right, and then because it's x4, it ends in the same direction on the left, correct? So I have this like W-shaped graph. If I go to the point 1 and -5, and I draw a slope of -2 over 1, so I go down 2 over 1, down 2 over 1, down 2 over 1, or up 2 left 1, up 2 left 1, up 2 left 1, and I drew a line at that point, it would be a perfect tangent line that would only cross through 1 and -5, right? So we would use the point 1 and -5, and we'd use the tangent slope that I just found, -2 over 1, and boom, 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 draw it, I have a tangent line. Yeah. D, find an equation of the tangent line. What's the fastest way to do an equation of the tangent line? Point slope form. Y minus y1 equals m times x minus x1. I showed it to you yesterday. It's literally just the slope formula with that x1 moved up, multiplied up. So your formula is y minus y1 equals m times x minus x1. Remember, it's the slope, just taking that x minus x1 and bringing it up to the, boom, up with the m, instead of leaving it in slope form. And then I can go y minus a minus 5, so plus 5, equals -2 x minus 1. Because I need to fill in the x1 and the y1 are a point on the original. What was the point on the original that it gave me? 1 and -5, right? And what was my tangent slope I found? -2. Then they want us to find an equation of the normal. An equation of the normal. So what's m normal? M normal is 1/2, because I take the -2 and I need to flip it so that it actually runs the right direction, 90 degrees perpendicular to the other one. And if it's a negative, it has to become positive. So it's going to be 1/2. And then I can just do point slope form. Y minus 5, so 5, equals 1/2 x minus 1. And then you could always put it into slope form and then distribute and collect to one side if they had it in y equals mx plus b, right? So you can always put it into point slope form. Yeah. You need to use the coordinate that they gave you on the original, right? Yeah. They just, that's the original point. Yeah. It's just labeling. And you could label it y minus y smiley face, x minus x smiley face, as long as you labeled the point x smiley face, y smiley face. Yep. Because it says normal. It's the normal slope. So you flip and change signs. Okay. Find the point on the graph of f of x equals 4x cubed minus 12x squared plus 2, where f has a horizontal line. Horizontal lines have slope of what? 0. So we're literally going to look for, whenever you read horizontal tangent line, they're literally saying when m tan equals 0. Just like in 30-1 when I said it is a factor, you would say the remainder is 0, or I say on the unit circle, you'd say, oh, I fill it into x squared plus y squared equals 1. Same thing in calc here. If it says horizontal tangent line, they're indirectly telling you that m tan equals 0. So I need to find m tan first. M tangent is just what? The first derivative. So we take the 4, we drop the 3 in front, it becomes a, what's 4 times 3? 12. X to the 2 minus, drop the 2 in front with the 12 and I get 24. X to the 1, which I don't have to write. And what happens with constants? They disappear. Now, normally that would be it, and I'd plug in for my x and I'd get my m tangent. We agree? But remember how we've done questions like this before, where they've made us solve for x, and how they've made us solve for x is they give us a value for y, and then we need to solve for x. Here they gave us a value for y. They told us m tangent is 0. So we're just using previous skills now. So our m tan is 0 equals 12x squared minus 24x. And now we just need to solve for x. What can we do? GCF of and x. And then we're left with x minus 2. So our two x values are 0 and 2. Which is fantastic, except it asked us to find the, I should have said points. That's a typo. Find the points on the graph. 0, 2. It's just that extra step where you set them equal to 0 and so on. Yeah. You got it. So we need a point. The points are always on the what? The original graph. So I need to plug them back into here. So if I went f of 0, I would get 4 and 0 cubed minus 12 times 0 squared plus 2. And so f0 just equals 2. So my one point is at 0, 2. And then my other one is that f of 2 equals 4 times 2 cubed minus 12 times 2 squared plus 2. So I get 4 times 8 minus 12 times 4 plus 2, which is 32 minus 48 plus 2, which is? So my other coordinate is at 2 and negative 14. I know I said it was a typo. Yeah. So where is f prime of x greater than 0 and where is f prime of x less than 0? So what we need to do is we need to make ourselves a little number line when they ask these questions. So I make a number line like this and I put 0 on it and 2. Why do I do that? Zero and 2 were what happened? The tangents were 2. No. What did I just find? What is 0 and 2? The points for the tangent line is what? Horizontal, where the tangent line is 0. We agree? Is 0 positive or negative? No. So we list those 2 points. They're called our critical numbers, and we'll deal with them next unit. But this is just a little glimpse into the next unit. So we list them because they're where m tangent equals 0. This is where m tangent equals 0. So they're neither positive nor negative slopes, right? Then how can we determine where they're positive and negative slopes? We look at all the values around it. So what would be a value on this side of the 0? What could we pick? I would not pick negative 28. I'm going to go with negative 1. And then between 0 and 2, what about 0, 2? What's between that? 1. And then 2 and onwards? I'm going to do 3. You guys are trying to make this complex. I am picking lazy, okay? That's the way I go. Now we need to find out where the first derivative is greater than 0 or the first derivative is less than 0. So where are we going to plug those red numbers into? The first derivative. Because where it's greater than 0, I'm going to get a first derivative answer that's going to be positive or negative. So I'm going to plug each one of these in. So I'm going to find f prime of negative 1, what the answer is. F prime of 1. F prime of 3, right? And I always plug them into my nice GCF form, and I'll show you why. So I'm going to go 12 times negative 1. And then I'm going to go negative 1 minus 2. So it's going to be a negative times a negative. Negative times a negative, which gets me a positive. So I'm going to end up with a positive number here if I put in any numbers. Negative 1 minus 2 is negative 3. You're right. Negative times a negative is a positive. Yep. I plugged it into the derivative formula. So you always plug it into the reduced form because then you can find your sign quickly. Do I actually care what the y value is? Did it ask me what the y values are? No, it just asked me if they're positive or negative. So yes, you could work your way through and do the math on this and say it's positive 36. But did I care what if it was positive 36? I just cared that it was positive. Now I could go 12 times 1 in brackets times 1 minus 2. I always pick the reduced form because it's easier to tell your signs. So I'm going to get a positive times a negative, so I'm actually going to get a negative number, right? It ends up being negative 12, but do I actually care? Unless I'm sketching the first derivative graph, I don't care what that y value is. I care that it's negative. Now if I fill any value between 0 and 2 in, I'm actually going to get a negative. Now if I fill in any value greater than 2, so I'm filling in 3, 12 times 3, and then 3 minus 2, I'm going to get a positive. 36 times 1 is 36. So if I have to state where f prime of x is greater than 0, I would say when, so I give actual domains here. So where is it positive? It's positive from here to here, open dot. Why would I say open dot? Because at 0, it's actually equal to 0. So I would say it's positive from negative infinity to 0 round bracket. This is a domain, not a coordinate, right? Or, which is a union. I use a union symbol. Where else is it positive? From 2 to infinity. It's an open dot because if it was a closed dot, these are zeros. These aren't positive nor negative. They're slopes of 0. Yeah, but the slope isn't positive at 0. The slope is 0 at 0. Right? No, it can't equal these ever. These ones are neither positive nor negative. They're equal to 0.
No, like in the question where it says where
Yeah, but then they would appear in both. They'll never ask that. Yeah. I get what you're saying, but for what we need this for in the next unit, they're not going to ask equal to. And then where f prime of x is less than 0, it's between here and here, so 0 and 2. The e to the x part, and then we're going to start product rule tomorrow. So there's homework at the end of this. You can do any of it that doesn't have an e to the x in it. If any of the questions have this in it, don't do them, because we haven't went over that yet. So if you look at the question, you're like, I can't do it, Lepp, and you put your hand up and you bring it in at scheduled help, and it has an e to the x, I know you didn't listen to me right now. And then I'm just going to pull this podcast out. I'm not going to talk to you. and I'm going to replay it to this very point.
It's gonna be me.